All right, so let's talk about section 7.1, scale diagrams and enlargements. Please write down your learning outcome into your learning journal. You are going to draw and interpret scale diagrams of two-dimensional shapes, 2D shapes. All right, so let's get started in your booklet. And first of all, it says a diagram that is an enlargement or a reduction of another diagram is called a scale diagram. And the scale factor is the relationship between the matching lengths on the two diagrams. So scale diagram, we say sometimes that this picture is 10 times as large as the actual object. We could say that it's magnified 500 times, meaning the object that we were looking at is smaller than it appears once it's been magnified. So you've heard these terms being used before. And put this into your learning journal, please. Oh, I need a pen, one sec. So this, to find the scale factor of a scale diagram, you divide the length on the diagram by the length on the original diagram. So length on the scale diagram is what you're doing, and length on the original is what it actually is. All right. So example number 1 says, here is a scale diagram of a pin. The actual length of the pin is 13 millimeters. Find the scale factor of the diagram. All right, so in order for us to be able to find the scale factor of the diagram, what we need to do, remember that we just talked about, no, you go away, please. We need to take the length on the diagram divided by the length on the original. Okay. So diagram over original. So you need O-R-I-G-I-N. You need to get a ruler, okay? Because you need to measure the length of the original, okay? It says, or sorry, you need to measure the length on the diagram. It says the actual length of the pin is 13 millimeters. So that's going to go on the bottom. That's original. We need to know what the length on the diagram is. So you need to get a ruler out, and you need to measure the length on your paper. I'm going to do the same. So hopefully you have a ruler. If not, you can borrow one from class. And notice that the actual length is given in millimeters, so you're going to have to measure the diagram in millimeters. When I measure, it looks roughly 38 millimeters. So hopefully that's what you got, similar. I can't measure it here on the smart board or smart recording thing. I don't think it's going to work because it's been skewed. I'm sure I don't have a ruler. Yeah. So, now we know that this picture is bigger than what a pin actually is, or else it would be a pretty big pin. So when we take 38 and we divide by 13, we get roughly 2.9. Okay? And that makes sense. It seems like it's, you know, like 13 millimeters is only, you know, 1.3 centimeters. That's not very big. This is clearly bigger than 13 millimeters. So it makes sense that it's being magnified about 3 times. Okay? So you can put 2.9. It was 2.92 on the calculator, but you can round it off to 2.9. So picture the diagram, or lengthen the diagram divided by the length of what it really is. So in the check here, it asks you to find the scale factor for each diagram. So I'm going to pause here. You try the check, number 1, A and B, and then we'll come back and see how you did. All right, so this check kind of helps you. It guides you through the question. This might be one of the times that the check might be helpful. All right, so it says that the actual length of the ant is 6 millimeters. And what it asks you to do is measure the length of the ant in the diagram in centimeters or in millimeters. So because it gives the actual length as 6 millimeters, which goes here, length of ant, 6 goes on the bottom, we should measure the length of the ant on this picture in millimeters. So I'm measuring it right now. I get roughly 33. So it's 33 millimeters, which you know is 3.3 centimeters. Not important, but it's there. So 33 divided by, that's what this line is, 6. So 33 divided by 6 is 5.5. So hopefully you got something around there. Now, keep in mind you're measuring. You might have got 34, you might have got 32. You just need to be in the ballpark. And when I mark your test, I'll just be looking to see that your answer is reasonable. Remember, ants are really small. This picture is way bigger than an ant, so our scale factor has to be more than 1. It's an enlargement. So your answer is going to be, this is a 5.5, the pen's being weird. So your scale factor obviously has to be bigger because it's being magnified. Okay. Now, B says the length of, this is the original here, and this is the scale diagram. So again, my original is smaller than my picture, so my scale factor has to be more than 1. It's bigger than what it was. So the length of the rectangle on this scale diagram, you don't got to measure this time. We can actually just count squares. Okay, so the length of the original is 1, 2, 3. So I'm going to put that here. The length of the original is 3. And then the length on the scale is 1, 2, 3, 4, 5, 6, 7, 8, 9. So remember, scale factor comes from length on scale diagram, which is 9, divided by length of original, which is 3. 9 divided by 3 is 3. It's 3 times as large. Okay? More than 1 because it's an enlargement. All right, now, example number 2 says, using a scale factor to determine dimensions. So, it says this cylinder is enlarged by a scale factor of 5/2. If you want, you can convert that to a decimal, 2.5. And it says find the dimensions of the enlargement. So this cylinder is to be enlarged. So this is the original. And then what they're saying is they're going to have a really big picture of it. They want to know what are the dimensions when you enlarge it. Okay? So what we're going to do is, because we're enlarging it, we're going to take the original dimensions and we're going to simply multiply them by 5/2 or 2.5. Okay, that's all we have to do. Okay, we're enlarging. So my new, if this is my enlargement, this new diameter on the cylinder would be what 2 times 2.5 is, which of course is 5. And the height, here to here, is 5 times 2.5, which is 12.5. Okay? So the dimensions are going to be diameter 5, height of 12.5. So give that a try on the check. You've got A and B to do, and it kind of brings you through it. So go ahead and try that and come back. Okay, so the first example, number 1A, it says a photo has dimensions of 10 by 15. If it helps, draw a little picture. A photo is a rectangle. 10 smaller than 15, so I'm going to put 10 on the smaller side and 15 here. Okay, so that's an example. So a photo has dimensions of 10 by 15. Enlargements are to be made with each scale factor below. Find the dimensions of the enlargement. Okay, now over here it says the length of the rectangle is always the longer dimension. 15 is longer than 10, so we will say the photo's length is 15 and the width is 10. So it says it wants it to be 4 times as large. So the length will be 4 times 15, which is 60. And it's going to be 4 times 10, which is 40. So the enlargement has dimensions of 60 by, I know it looks like times, but by 40. Okay, so once we take our photo and we enlarge it. Okay, it's going to be way bigger. It's going to be 60 by 40. All right, example number B. Scale factors 13/4. Okay, so nobody likes to multiply by fractions, so it's much simpler to just take 13/4 and write it as a decimal. So 13/4 means 13 divided by 4. Get on your calculator, unless you can do it in your head. 13 divided by 4 is 3.25. So remember our photo, I can't remember, one sec, I gotta go back. Our photo was 10 by 15. Okay, length of original photo, was 15. Remember the length is the longer one. Length of original was 15, width of original was 10. The length of the enlargement, I wonder what they want here. Well, we're just going to take 15 and we're going to multiply by 3.25. So get out your calculator, take 15, multiply by 3.25 to get 48.75. The width is 10. We're going to enlarge that by 3.25. I really hope that you don't feel the need to take out your calculator. We're multiplying by 10. It just becomes 32.5. So the enlargement has dimensions of 48.75 by 32.5. So I think that you will find this lesson quite easy. It doesn't get any more difficult than that. Remember that when you're enlarging, your scale factor has to be more than 1. Okay? Good luck on the practice.